Walking Stick Library presents Why Contrails Are Not Geoengineering with your librarian hostess with the mostest, Eileen Kramer. And remember, you can catch this stream live on Twitch.
That around here, but it's true. If your search topic is tight and very detailed, how do you come up with stuff like that? Well, you guys saw. We came up by watching a video that on CloudHub. If you're open to your world, topics are going to jump at you. They're in all the stuff. A few nights ago, we found lichens walking on the sidewalk when I went out to see the King and the Queen. Topics live everywhere. And Seth Holehouse at CloudHub, otherwise known as Man in America, but his real name is Holehouse. Seth Holehouse, he was a former jewelry dealer. He probably still sells gold. I'm going to go to my subscribed channels and get him because he has an interesting one, has a very interesting video. And I'm going to stop this. I'm going to let it go till we see his face on the screen. Okay, Seth, we're ready to go. Okay, I got him ready to go. And he did a video on a topic we've done before, but we're going to do it a little differently this time around. We did a whole thing on jet fuel and jet emissions because those things have to be nasty. But they're not contrails. Contrails are mostly water. And contrails are not chemtrails, they're contrails. Those things you see in the sky, we used to call it skywriting when I was a kid, and it was really cool. Those little streaks you see when airplanes go flying overhead, those are contrails. They are jet emissions. They are mostly water. They have some other nasties in them, but they're mostly water. So we will look up what is in them. But first, we're going to watch our friend Seth, the Man in America. Up we go, and let me just make sure that my curtain is up. Let me make sure my curtain's up, which it is. Let me check my squawk. If anybody's come by, this would be a great time because we're starting a new topic. Okay, Seth, take it away.
To Man in America, a voice of reason in a world gone mad. I'm your host, Seth Holehouse. So, if you look around, and you probably have been thinking this, it just seems like on the average day, there's about 1,000 different ways that we're being poisoned. Whether it's the fluoride in our water, the stuff they're putting into the medications and shoving into the arms of our kids, the food, the pharmaceutical industry, I mean, the list just goes on and on and on. But I have to say that as someone that lives out in the country, we eat mostly organic, we're so careful with every aspect of our lives. Me and my wife, and we have 2 little children. The one thing that gets under my skin more than anything, and both figuratively and literally, is geoengineering. It's what they're spraying in the skies. And this is the one thing that I can't wrap my head around in getting over the frustration of this, is the fact that, I have like a 1-year-old and a 4-year-old. And we do everything to make sure that they have a safe environment. We don't put poisons into them, as you imagine. But I take them outside to play with their dogs or go feed the chickens. I look up, and I see a cloudy, it was sunny morning, and it's sunny to start the day. Look up, you see the streaks, you see the clouds. All of a sudden, my little girl's coughing. You can feel it in the air as a metallic taste. To me, this is the most reprehensible action of the current government or the current whoever's doing it. It's just like, who gives you the right? Who gives you the right to fly overhead of my private property and just dump chemicals on me? And take my organic garden, and it's no longer organic because who knows what's being dumped on it. It just it is this.
Okay, we are where we need to be. Now, Seth thinks he's being poisoned with chemtrails, which I'm going to do a quick, I want to just get down a bit. I'm going to do a quick switcheroo. And again, they're really contrails. They're jet exhausts. Chemtrails. Jet exhausts are nasty, but I'll admit they're nasty. But they're not, they're mostly water. And we'll go and prove that. Contrails. And we're going to ask, what is in them? What is in them? And since you don't always see them, I don't want that. All right. I'm going back to 100% anyway. When do they occur? How do they occur? We need a brief one. And the last time out, we did look at jet fuel, which is nasty. Especially if you're working at an airport, which this guy isn't. So, yeah, for some people, this does indeed have a risk. Not to mention all of the carbon. This is definitely a carbon spewer. Definitely not good for global warming and all that stuff. So that's one thing. The other question is, are they geoengineering? This time we really are going to do both parts. And the way we answer that, once we know what a contrail is not just, oh yeah, they're this other thing. We're going to ask, what? Because there is geoengineering that does involve putting things in the sky. And the question I want to know is, are they doing it? Now, I know, fix the typo, Kramer. When we start with something like this, and if you're curious, whenever I sort of switch questions, I switch colors. This is the name of the topic, so they're both yellow. What about, this is the contrail area, details about contrails. What is geoengineering? And are we doing it currently? That's what we're asking, 4 questions, basically. And the reason that we're going to believe what we find is that scientists want to make a name for themselves. So if there is geoengineering going on, it's going to produce a trail of scientific papers. We tried this in the lab. We're going to do this in the sky to reduce carbon. We're going to this, that, and the other. It's not being done secretly because nobody gets paid well enough to do it secretly. The scientists get their grants. They beg, plead for their grants. They're losing their grants all over the place, Seth. And they get research grants. They get money from different places. Then they go out and publish articles so they can move up the academic ladder. And due to publish or perish, if there's geoengineering going on, you will see, I know, typo, you will see articles. You will see articles. So, First thing we're going to need is a definition of contrails. And we have our favorite place to go for that. We're going to go to Wikipedia, because that should, and Wikipedia on science gets pretty darn dense, which we like. Dense is good. Okay, so we're going to look up contrails in Wikipedia. Very basic Google search for starters. Contrails. And Wikipedia, this is a semi-known item search. We want to build this piece by piece, so we're going to build it piece by piece. There we are. And we can run that on Google. It's fairly basic. Okay. Contrails. And the and is implicit, but I'm putting it in anyway. Wikipedia. Contrail. Okay. And here they talk about a chemtrail conspiracy theory, but this is a contrail. Sometimes they stick around in the sky longer than that. So contrail is short for condensation trail or vapor trail, a line-shaped cloud produced by aircraft engine exhaust or changes in air pressure, typically at aircraft cruising altitude several kilometers above the Earth's surface. They are composed primarily of water in the form of ice crystals. The combination of water vapor in aircraft engine exhaust and the low ambient temperatures at high altitudes causes the trail's formation. Impurities in engine exhaust from the fuel, including soot and sulfur compounds, 0.5% by weight in jet fuel, 0.05% by weight in jet fuel, provide some particles that serve as cloud condensation nuclei for water droplet growth in the exhaust. If water droplets form, they can freeze to form ice particles and compose a contrail. Their formation can also be triggered by changes in pressure in wingtip vortices or the air over the entire wing surface. Contrails and other clouds caused directly by human activity are called homogeneous. Yeah, there's a bit of soot and sulfur in those things. So they're not clean water, but they're dirty water. Okay. Vapor trails produced by rockets are referred to as missile contrails or rocket contrails. Contrails as a result of engine exhaust. Engine exhaust is predominantly made up of water and carbon dioxide, the combustion products of hydrocarbon fuels. Many other chemical byproducts of incomplete hydrocarbon fuel consumption, including volatile organic compounds, inorganic gases, polycyclic aromatic hydrocarbons, oxygenated organics, alcohols, and ozone. Blech! Okay, so these are dirty water. The particles of soot have been observed at lower concentrations. The exact quality is a function of engine type and basic combustion, with up to 30% of aircraft exhaust being unburned fuel. So these are nasty, but they're not jetted. They are nasty, but they're nasty in their own way. Right here, biological and health effects of exposure to kerosene-based fuels. You have every right to not like what you're getting. Yeah, there is pollution going on at high altitudes as this water vapor emerges into a cold environment. The localized increase in water vapor can raise the relative humidity of the air past saturation point. The vapor then condenses into tiny water droplets which freeze. If the temperature is low enough, these millions of tiny water droplets and or ice crystals, loose cable folks, but it's back. These millions of tiny water droplets and or ice crystals form the contrails. The time taken for the vapor to cool is enough to condense accounts for the contrail forming some distance behind the aircraft. At high altitude, supercooled water vapor requires a trigger to encourage deposition or condensation. Exhaust particles in the aircraft's exhaust act as the trigger, causing the trapped vapor to condense rapidly. So the answer here is they're made of dirty water. And there is some air pollution in them, but they are water. They are not chemicals designed to change the atmosphere. So apparently they're not geoengineering, but they are dirty water. So do we have cause for concern? H2O is in them, and pollution. Small amounts of pollution and CO2, they're not nice things. And CO2, and they're due to cold water and cold air. Water, soot, and cold air. Soot and cold air. Water, soot, and cold air. That's your contrails, folks. Now, that leaves half a question unanswered. And the reason it leaves half a question unanswered is, sure, that's what's in a contrail. But couldn't geoengineering look like a contrail? Very good question. Let's take a look. And we're going to want the GSU library right here. And we are going to look up geoengineering. But we're going to do it in the catalog because we want a Geoengineering for Dummies books. I don't have the patience to go into the weeds tonight. Go. I'm just going to type that in there. And I don't know what that is, but I'm going to open that. That is a magazine. What I need to do is not have it go back to 1985. That's number one. I think I'd like it to be as far up as 2010. Let's refine. And let's make this full. Let's make this books. And let's make this full access online. Okay. There's a whole conference on it. There's a good one down here. One that the National Academy published. And this is a good one right here, number 16, Redirecting Sunlight. And I did walk through on this. Here's one from 2015, Planet Remade, How Geoengineering Could Change the World. We could do either of these. I'm going to take the one I don't know because I'm curious. It's a JSTOR Books collection, and we're going to let it take us in. And we have a table of contents, introduction, 2 questions. Okay. We could dim the noonday sun. And this says a volcanic eruption does not have to be as powerful as Pinatubo to inspire awe and terror. Matt Wilson, a British volcanologist who works on climate engineering, experienced a heady rush of the sublime during the 1995 eruption of the Soufriere Hills Island on Surat. It was the eruption of the year rather than the eruption of the century, but the sight of the sky turned solid and rushing towards him remains vivid and almost incomprehensible. It feels like the falling off of the earth, the idea that human ingenuity can deliver the same impact as Vulcan's wrath. Okay, I think this is one we want. Okay. The idea that human ingenuity can deliver the same impact as Vulcan's wrath seems implausible, even impious, but it is an everyday truth of the Anthropocene. Humans outstrip nature all time in ways that just a few centuries ago, at the time of, say, Tambora, would have shocked all those romantic spirits looking to high mountains in wild weather for the thrill of the sublime. They bridge the deepest chasms, light the darkest night, dam the greatest rivers, surpass almost every limit you could imagine for mammals, not even 2 meters tall, with brains smaller than melons. The sense of the awe-inspiring other against which humans measure themselves is now readily provided by their own works, as it is by those of nature. There is now a phrase of the historian David Nye, a technological sublime. An overwhelming of imagination, as he puts it, undermines all notions of limitation. The usurping of nature can be spectacular. Nye points to huge engineering projects, atomic weapons, rockets to the moon, but it does not have to be. Some tasks of Titans can be accomplished with comparative ease. Creating a veil in the stratosphere looks like one of those tasks. The manner in which Pinatubo delivered 20 million tons of sulfur dioxide to the atmosphere was, after all, monstrously inefficient. The gas rose because it was hot and buoyant. Keeping it hot and buoyant when left to itself, it would have quickly cooled as it rose. Was the business of billions of tons of hot rock thrown up into the air with it. A system designed to lift the gas alone could do it with a lot less palaver. In principle, a ton of anything could be lifted to the overworld with about 70 kilowatt hours of energy, which is not a great deal, less in fact than you get from burning 10 liters of gasoline. If you spread the process out over a year, you could lift 20 million tons into the stratosphere with a constant output of about 160 megawatts. The sort of power you get from a power station running a couple of modern gas turbines. In practice, mechanisms for lifting gas are not quite that efficient, but they are still quite manageable in energy terms. The obvious way to do it would be to lift the gas in aircraft, an option that was explored quite recently in a 2000 study by the Aurora Flight Sciences, a company that builds, among other things, stratospheric research aircraft. The study was commissioned by David Keith, a researcher whom we met at the introduction in the University of Calgary, about how much it might cost his company, Carbon Engineering, to suck carbon dioxide out of the atmosphere. Professors don't often have the wherewithal to commission studies on subjects they are interested in from commercial aircraft makers, but Keith, probably the single most influential researcher in climate geoengineering field, is not a typical professor. Among those other things, he is friends with Kevin Caldera, an Earth systems scientist at the Carnegie Institute. And they have, for most of the past decade, held the purse strings of a fund created by Bill Gates and some of his former employees to pay for research in climate engineering. This is separate from the Gates investment in carbon engineering, though obviously there's some common cause in terms of Gates' respect for Keith's abilities. The Aurora analysis concluded that in a pinch you could deliver 1 million tons of something with the density about the same as that of water to some parts of the stratosphere with various technologies already up and flying, such as a fleet of 14 Boeing 747 jumbo jets. Setting the system would cost a bit less than $1 billion. A year's operating cost would be another $1 billion or so. It is worth noting that a number of people think such an airliner scheme is already going on, except on a much grander scale. There is a network of observers, activists, and fellow travelers around the world devoted to the belief that the condensation trails left by some of our aircraft and other aircraft are not clouds fed by water vapor left in the wake of an aircraft's engines, as all authorities insist, as we found out, but instead noxious substances deliberately sprayed into the atmosphere as part of a covert government program, not contrails, but chemtrails. There is no real consensus on what the purpose of these chemtrails might be. Mind control, compulsory sterilization are sometimes suggested, as are weather modification, and even the deliberate encouragement of global warming. But whatever it is, it is assumed to be nefarious. For evidence, chemtrailers point to photographs showing aircraft trails in a profusion or pattern, which they can see no explanation other than covert spraying program. The planes are looping around on themselves, or rather follow a path from A to B. Trails that follow one plane but not another, despite two seeming to be in exactly the same part of the sky, a purposefully telltale phenomenon known as one with, one without trails, with different appearances coming from the wings of a single plane. They pay detailed attention to pictures that show small nozzles and vents on the wings and engine nacelles of airliners, but to discontinuities and discrepancies in the data available on websites that track civilian aircraft. There are clear dissimilarities between the beliefs of chemtrailers and those of many other conspiracy theorists. I know of explanations for many of the phenomena they attribute to covert spraying, which I find far more persuasive when they describe things for which I know of no alternative explanation. Chemtrailers have become a fixture of public discussion. And again, to return to the practicalities of real, which is to say purely notional atmospheric geoengineering assessed by the Aurora report, spraying out aerosols behind jumbo jets would be far from ideal. With a ceiling of 14 kilometers, 747s can't get above the tropopause in the tropics. That is above the troposphere where we live, to the stratosphere. You have to get up very high. Where is it at its highest? They would only be able to put aerosols into the stratosphere in temperate and high latitudes, and then only into the lowest reaches. So you've got to get one of the reasons that this is not geoengineering is you have to get that contrails are not geoengineering is that you have to get the hydrogen sulfide up higher, besides the fact that they are water. That would limit the aerosol's ability to stay up for a long time and spread around the world. A high-performance fighter such as the American F-15 can get above the tropical tropopause, but it would not be able to loiter there, as such aircraft are poorly suited to spraying out gas, because their payloads are much smaller than you would need, almost 10 times as many fighters as you would jumbos, and a far larger ground operation. Fighters take 5 times more maintenance per hour of flight than passenger jets do. If you can get past the various regulatory and political problems that putting together an air force of that size might involve, you would be looking at costs of more than $10 billion a year. And a better solution, the report found, would be to design a new aircraft from scratch to fly between 20 and 25 kilometers. You'd want something a bit like a fattened U-2 with its long wings pointing almost straight out from the fuselage and engines modified to operate in air too thin for a normal jet. So you need to get this up really high. Now I've got more here. This turned out to be a really good one. Up here, this deals with geoengineering in the sky, reflecting sunlight, recommendations for solo geoengineering research governance. And we can just catch this. This is a National Academies publication, again, super important. And it was published, we want a date. 2021. So keep that date in mind, because these things age. Hello, I bet you're gone. Ah, you've survived a day. That's better than nothing. Okay, this is number 2. This was as of 4 years ago. And we're going to load, and we're going to look at what they actually do. This gives very human, understandable stuff. This chapter provides an overview of the current landscape, in quotes, of research and research governance related to solar geoengineering. which is what they do up in the sky, offering a critical departure point for thinking about future of the research and research governance enterprise. Building upon earlier analyses of the National Research Council 2015 study, following sections provide a brief discussion currently proposed solar geoengineering methods. And we review the current state of relevant technological, natural science, social science research, observations about synthesis across different research areas, and an overview of the current state of research governance. Okay. So we have three kinds of research. There are two main approaches considered here for increasing how much solar energy is reflected back into space. Stratospheric aerosol injection. See, they are thinking of this, but it has to be higher than most jet planes fly. And marine cloud brightening. You wouldn't be seeing that because you don't, Seth, because you live near Columbus, Ohio. I looked up where your business is. In addition, this report considers cirrus cloud thinning, which differs from other strategies in that it focuses on increasing outgoing long-wave radiation and thus is not technically solar geoengineering. Each of these approaches would affect Earth's radiation balance in different ways. They are described below and illustrated. So way up here in the stratosphere above the clouds is where you would spray aerosols. You would thin the clouds at this point by seeding them, and down here we have clouds a little further down. You would brighten them, and that might take place over the Great Lakes, even though they say it's marine. And here they have pictures, and here we go. Stratospheric aerosol injection. Stratospheric aerosol injection is the most studied and best understood of the SG approaches to date. It is based on increasing number of liquid and solid particles in the stratosphere where they can reflect sunlight. Unlike the highly turbulent troposphere, which is where the clouds are, the stratosphere is relatively stable, and the aerosols in this region of the atmosphere can remain for a year or more before being transported to the troposphere and eventually removed by sedimentation and precipitation. So, they're not falling on your kid if they're doing this. Large volcanic eruptions, the eruption of Mount Pinatubo in 1991, add significant amounts of hydrogen sulfide and sulfur dioxide into the stratosphere, where they are oxidized to form sulfuric acid, which forms reflective sulfate aerosols. Apparently at very high altitudes, acid rain is a fine thing. The Mount Pinatubo eruption is estimated to have cooled global mean temperatures by about 0.5 centigrade for 1 year or more. A similar effect in principle, could be achieved deliberately by adding SO2 or H2S gas, adding sulfate particles directly, or adding some solid particles such as calcite. While sulfate has the advantage that it is more directly analogous to material expelled by volcanoes, it also absorbs infrared radiation and can pose undesirable effects on atmospheric chemistry, known as acid rain. These concerns have motivated some exploration of other aerosol choices. Because aerosols spread relatively uniformly in longitude and are transported broadly poleward in latitude, during their lifetime in the stratosphere, the cooling effects of SAI would be inherently global. And by the way, they wouldn't have to be over your house, Seth, because they could spread. So, not a chemtrail that you're seeing, for obvious reasons. Regional scale climate impacts may vary considerably, however, and the details of impacts at this scale are highly uncertain and will depend on how SAI is deployed. MCB is based on the idea of cooling Earth by increasing reflectivity of low clouds over certain parts of the ocean. As an analog under the right conditions, the aerosol pollution from ships leaves behind a ship track caused by emitted aerosols acting as an additional cloud condensation nuclei. For the same total cloud water content, more droplets, more nuclei result in higher surface area and more reflective cloud. As it has been proposed, the same effect could be achieved by spraying a fine mist of salt water into the marine atmosphere. And you could do NRC 2015 provides a detailed review of the decades of research on aerosol marine cloud interactions. I wonder if they do any on the Great Lakes, including ship track studies. Yet despite this large research base, many uncertainties remain regarding MCB strategies, including limited understanding of aerosol cloud interactions and how these interactions could affect a cloud's total water content and lifespan. This understanding needs to be improved in order to reliably project where, when, and how much cloud albedo could be modified. Albedo is reflection. The expectation of MCB, marine cloud brightening, would be implemented at the regional level, potentially allowing more targeted interventions to protect a specific coral reef ecosystem. However, if the MCB forcing could only be applied over a relatively small fraction of the Earth's surface, actually reducing the global mean temperature would require a relatively larger radiative forcing to be applied over a smaller area, like inducing more spatially heterogeneous climate responses than SAI. It is also important to recognize that for MCB, the albedo modification effect is localized, but the resulting cooling effects are not, since the atmosphere will transport changes in heating to other areas. Cirrus clouds, those thin, wispy clouds composed primarily of ice crystals that form in the upper troposphere. That's where your chemtrails are. Warm the planet at higher latitude because they reduce outgoing long-wave radiation more than they reflect incoming sunlight. Reducing cirrus cover would thus produce a net cooling. It has been hypothesized, this is almost the opposite of contrails. It has been hypothesized that in the right conditions, it may possibly be possible to seed cirrus clouds with ice nuclei that would lead to fewer larger ice crystals with higher fall velocities, thus decreasing the lifetime and hence the cirrus cover. They'd rain or sleet. This approach would only work in locations where cirrus clouds form through homogeneous freezing, that is, where there are not currently enough ice nuclei to allow heterogeneous freezing. If there were already sufficient ice nuclei in some regions, then adding more could have the opposite effect, leading to more smaller ice particles with longer lifetimes. Okay, general research status. As general estimates reflecting roughly 1% of the sunlight that currently absorbs, as a general estimate, reflecting roughly 1% of the sunlight that Earth currently absorbs may be enough to counteract all of the warming caused by the current increase in atmospheric CO2 levels above the pre-industrial levels. Kravitz 2013 shows estimated solar reduction for CO2 forcing roughly 4 times larger than today's. However, even if an increase in the global mean temperature rise due to CO2 were fully compensated by solar geoengineering driven reduction in temperature, these different climate forcing mechanisms affect climate in different ways. Solar geoengineering conventions could lead to a variety of changes in regional scale temperature, precipitation patterns, and other impacts. Effects that are present are poorly understood and difficult to predict. For any of these SG methods, the climate response will depend on specific method of forcing as well as the spatial distribution of that forcing. This reality, together with existing uncertainties in climate modeling more generally, means that our ability to estimate climate responses and the downstream impact of these responses is currently limited as of 2021. And there has been significant research to date. You can see it in different disciplines. Most are in atmospheric and climate science. So, have they tried it? As of 2021, it appears no. But we can check now that we have the names. This is spinning. Which means we get to see if we get to see if they've tried it. I'm going to put us back at 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. We have names, and we can search these at GSU right down the front. And I'm going to make a box. Make sure we have the right color. Make sure we have the right color for the background. And I'm going to put us at 48, not 36. And what we're going to be looking at is, let me go back, let me check my chat. You're long gone. Okay. Stratospheric aerosol injection. Stratospheric aerosol injection. That's my first one. Stratospheric aerosol injection. Has anybody tried it, even on a small scale? And the other is marine cloud brightening. And I'm going to take Science Direct this time. So we're going to need a Google, and we're going to need to go to GSU libraries. It's good to do these in different databases. And we're going to go to GSU library, and we'll check out Science Direct, which is Elsevier, or we can do the big box, or we can do Web of Science. Any of these will work. I'm just going to run the search, a known items search. Throw the mud ball at the wall. What are you doing in the last 2 or 3 years? I don't need another quotation mark in there. And if you don't take me nicely, I'll go to Web of Science again. And you're slow as molasses in January, wouldn't you know it? And you want me to sign in. And we want this to take its time. And we want the last 5 years. (2024) Natural variability can mask forced permafrost response to stratospheric aerosol injection in the ARISE SA 1.5 simulations. So they've done a simulation in 2024. I don't know what that is, what UXM 1 is, but these are very recent. Kicking the can down the road, understanding the effects of deployment of stratospheric aerosol injection. Assessing the GEFDLESM41 climate response to stratospheric aerosol injection intended to avoid overshoot 2 degrees warming. Geophysical research letters. I don't have 2024. Okay, we'll try one of these. Try this one. And are they doing it is the question. So you don't have to go very far. Just have to look basically at the materials and methods to find out if they did this in a lab or on a computer or out in the wild. This is something we can understand, even if the science goes way into the weeds. And I've got a slow computer. I wonder if I'm being throttled. Come on, guys. There's nobody here but me-o. Stratospheric aerosol injection has been proposed as a method for mitigating risks and impact associated with anthropogenic climate change. One such risk is widespread permafrost thaw and associated carbon release. While permafrost has been shown to stabilize under different SAI scenarios, natural variability may mask this forced response and make it difficult to detect when SAI is stabilizing permafrost. Here we use the 10-member ensemble from the ARISE SA 1.5 simulations to assess the spread and projected active layer depth of permafrost temperature across boreal permafrost soils and specifically in 4 peatland Yodoma regions. The forced response in active layer depth and permafrost temperature quickly diverges between SAI and the non-SAI world, but individual ensemble members overlap for several years following SAI deployment. We found that due to projected permafrost variability, it may take more than a decade of SAI deployment to detect the effects of SAI on permafrost temperatures and almost 30 years to detect its effects on active layer depth. Not only does natural variability make it more difficult to detect SAI's influence, it could also affect the likelihood of reaching a permafrost tipping point. In some realizations, SAI fails to prevent a local tipping point that is reached in the non-SAI world. Our results underscore the importance of accounting for natural variability in assessment of SAI's potential influence. Okay, what I want are materials and methods. To explore the role of natural variability in the permafrost of SAI, we use output from 2 parallel 10-member climate simulations. Both simulations were run with fully coupled Community Earth System Model version 2, CSM2, blah, 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 in parentheses, lots in parentheses here. As the atmospheric component, a modified version of the Parallel Ocean Program version, and the ocean component, the Community Land Model, CLM5. And we can see what some of these are if we look. So this was done on a computer. It was not done in the wild. Nope. Okay, what is UKESM1? I have no idea, but this is going to tell me. Let's get the PDF and take a look-see. Spin, 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 very slow, very slow. I think the bastards are throttling this show, and it's 11 o'clock on a Sunday night. Okay, we didn't get in. We can try this one. This is RZIV. And there should be a PDF in here. There is. Okay. Climate change is a prevalent threat, and it is unlikely that current mitigation efforts will be enough to avoid unwanted impact. One potential option is to reduce climate change impact is the use of stratospheric aerosol injections. Even if stratospheric aerosol injection is ultimately deployed, it might be initiated only after some temperature target is exceeded. The consequences of such a delay are assessed herein. This study compares 2 cases with the same target global mean temperature above pre-industrial but start dates of 2035 or a delayed start in 2045. We make use of simulations of the Community Earth System Model version 2 and the whole atmosphere coupled chemistry model using SAI under SSP 245 emissions pathway. We find that delaying the start of deployment relative to target temperature necessitates a lower net radiative forcing and thus larger sulfur dioxide injection rates, even after surface temperatures converge to compensate for the extra energy absorbed by the Earth system. However, many surface climate differences between 2035 and 2045 start simulations appear to be small during the 10 to 25 years following the delayed SAI start, although longer simulations would be needed to assess any term impacts. In other words, this is again being done with a computer, folks. Let's see if I do better this time. I guess we're just not going to get in there. Okay, what is the GFLD? I don't know what the GFLD ESM41 is. Let's click a find it at GSU. It likes it better. And as long as, I think, has anybody tried anything outside is what we're wondering. Did they ever get outside? Oh, you don't like me. You like me now. In this work, we apply the GFDL Earth System Model to explore climate responses to atmospheric aerosol injections scenario that aims to restrict global warming to 2 degrees above pre-industrial levels. Under the CIMP6 overshoot scenario, simulations of stratospheric aerosol injection scenario with the CESM whole atmosphere community climate model showed nearly unchanged interhemispheric pole to equator surface temperature gradients relative to present day conditions around 2020 and reduced global impacts such as heat waves, sea ice melting, and shifting population patterns. Ding! So they're still doing mostly computer simulations. And remember, if they try something outside, they're going to want to publish it. So this is all done on the outside. Anybody with access to an academic library can do what I'm doing right now. Comparative planetology is a foundation for associating space law with solar geoengineering. We hit a law review. Okay, CESM2 we know is a computer model. Another computer model. Okay, under a not-so-white sky, visual impacts of stratospheric aerosol injection. Let's find it. And this is a 2025. That's really good that we've got one that's that new. That was ugly. I'm sorry, that was ugly. This is a letter, which means it's a short article. Stratospheric aerosol injection could change the sky's appearance. This could play a role in shaping public perceptions of SAI. Noticeability depends strongly on tropospheric aerosol optical depth and the amount of SAI used. We aim to quantify the noticeability of changes in sky color and brightness due to SAI. We use a 3D visible light radiative transfer package to generate cloudless sky images during high sunset, and twilight. Under SAI from the reference point of a ground observer. We consider 3 aerosol types, H2SO4, calcium carbonate, and diamond. Woo, diamonds. You hear that, Seth? We consider stratospheric aerosol loadings required to produce a radiative forcing of -1, -2, and -4 W per meter squared, and we use the population density and AOD data to compute the distribution of atmospheric optical depth people experience, and then simulate sky images for the 10th, 50th, and 90th percentiles of distribution. We compare the simulated changes in color and brightness to experimental measurements of minimum thresholds humans can detect. The 3 aerosol types cause similar changes, except most notably the diamond aerosol increases brightness of the solar aureole by roughly 3 to 5 times than do the H sulfuric acid and calcium carbonate. During high sun, sky whitening from sulfate SAI at -2 WM is undetectable for roughly half of the observers chosen randomly from the global population. For the remainder of the population, we expect whitening to still be unnoticeable for all but the most astute observers, aided by color samples. Brightening and enlargement of the solar aureole is most visible during the high sun, while changes near twilight would be the most noticeable impact of SAI. We cannot evaluate the fraction of the population who would notice these changes. Okay. So you're not going to see stripes and streaks. SAI does not produce stripes and streaks. So I'm going to come back inside for now. We could do marine cloud brightening and see what we get, how we get with that. Again, I'm worried that nobody has, so far, nobody has done it outside. They've only done it on a computer. It also doesn't produce stripes and streaks. Now let's try our other one here. And I'm going to put quotes around it because I'm a good human and I put quotes around my stuff. Fetch. We'll fetch this sucker too. And we want this to be the last 5 years. Okay. Governing marine cloud brightening for ecosystem conservation. Targeted marine cloud brightening can dampen El Nino. This is ARZIV. This is 2024. Let's have a look. And again, we can get the PDF and embiggen. And many record-breaking climate extremes arise from both greenhouse gas-induced warming and natural climate variability. Marine cloud brightening, a solar geoengineering strategy originally proposed to reduce long-term warming, could potentially mitigate extreme events by instead targeting seasonal phenomena such as El Nino, the El Nino Southern Oscillation. By exploiting the 2019-2020 wildfire experiment of opportunity, we show that simulated marine cloud brightening in the Pacific reproduces observed cloud changes and induces La Nina responses. We then explore how cloud brightening timing and duration modifies the 1997-98 and 2015-2016 El Nino events. We find earliest and longest interventions reflectively restore neutral ENSO conditions and dampen El Nino's impact. Solar geoengineering targets climate variability could complement tools such as ENSO for forecasting. So this is an observational study. Nobody seeded any clouds. Okay. A review of plume dispersion and measurement techniques applicable to marine cloud seeding. Let's try it. And we need to make this bigger. Here we are. Rising sea surface temperatures are causing more frequent and intense coral bleaching events, threatening long-term survival of coral reefs globally. Marine cloud, apparently nobody's doing this on a lake, on the Great Lakes. Marine cloud brightening is a proposed intervention that could be applied to reduce the risk and severity of coral bleaching. The effectiveness of logistical feasibility of this technique depends on what fraction of the sea salt aerosols are incorporated into clouds after being emitted from seawater spraying operation at the ocean surface. Here we review, so nobody's getting up in the air to do this, they're spraying this up into the clouds from a ship. Here we review the literature on the dispersion of MCB sea salt aerosols from a point source within the marine boundary layer. We focus our consideration on the process and mechanisms and current ability to predict the horizontal and vertical evolution of the plume from its generational at surface level to its downwind dispersion and mixing to cloud height. Overall, we found that in the more than 3 decades since the MCB concept was first proposed, there have been 8 studies investigating this aspect of MCB, which is crucial to informing engineering systems design, marine logistics, assessing overall potential impact and effectiveness of MCB. So, all right. A protocol for model intercomparison of impacts of marine cloud brightening. And again, this is 2024. Let's get the PDF and hope it opens. Sometimes these are slower than we want them to be. Okay, I'm not having any luck. We're going back. Which is a shame because I really would like to find this. What I could do, if I go to the very bottom, was I could go to the database. We can get the online full text if it will spin. It did. Okay, a modeling protocol defined by a series of climate model simulations with specified model input is introduced. Studies using these simulations are designed to improve the understanding of climate impacts using a strategy for climate intervention known as marine cloud brightening in specific regions. Therefore, the protocol is called MCBREG, where REG stands for region. The model simulations are not intended to assess the consequences of realistic MCB deployment intended to achieve specific climate targets, but instead to expose responses to interventions in 6 regions with pervasive cloud systems that are often considered candidates for such deployment. So, still on the computer there. They're doing some of the engineering. They're not actually spraying clouds, however. And again, this is slow as molasses in January. Okay, here's another one with a model. CSCM2 is a model. That's just doing a computer. Marine cloud bright impacts on tipping points using an AI implementation of a fluctuation dissipation theorem. Just this, I don't know if this gets out anywhere, but we can view this at RZIV. And don't worry, I think they're just doing it on a computer. We can tell by looking at this. Marine cloud brightening is a proposed climate intervention technology to partially offset greenhouse gas warming and avoid crossing climate tipping points. The impacts of marine cloud brightening on regional climate are typically estimated using the computationally expensive Earth system model simulations, preventing a thorough assessment of the large possibility space of potential MCB interventions. Here we describe an AI model named AI-BETO, a BETO, that can be used to rapidly project climate response to forcings via a novel application of the fluctuating dissipation theorem. So nobody's spraying clouds. This is all being done on a computer. AI-BETO is a multi-layer perceptron MLP model. And I don't know what that is, but I know that they usually have lots of layers, that uses MAPS monthly mean radiation anomalies and surface climate anomalies at a range of time lags by leveraging a large existing data set of the ESM simulations containing internal climate noise. We use AI-BETO to construct a fluctuating dissipation theorem operator that successfully projects climate response to marine cloud brightening forcing when evaluated against ESM simulations. Okay, still on the computer. Now there's one thing we probably want to know. And that's going to take one of these guys. I'm going to get my color back. And I'm going to push us up just a little bit so we have some space. Since Seth, we were looking at Seth's videos, and he's in Ohio. Did they ever do any marine cloud? Is anyone considering doing marine cloud brightening over fresh water, like the Great Lakes? So what we're going to do is remove the background, bink, bring down the size, marine, cloud, brightening, and of course you won't see any chemtrails from this because they're squirting a hose from a ship. The other one is too far up in the sky and doesn't make streaks and stripes. here, we're looking for lakes, L-A-K-E. Great Lakes, Great Salt Lake, any big lakes out there. And I'm going to go back to this and I'm going to change my, I don't have any filters up for this, that's nice. I'm just going to add this then, A-N-D-L-A-K-E. I could say fresh water, but I think we're looking at lakes primarily. Has anyone done this over a lake or thought about doing it on a lake? Salt Lake aerosol overview, emissions, chemical composition. Your letters. Exploring ship track spreading rates with physics-informed Langevin. Okay, that is useful. Peering into that, they're used often as a model for marine cloud brightening. Peering into cloud physics using ultra-fine resolution radar and LiDAR systems. Okay. We could take any of these. Let's see if they did it on a lake. Now, we may not be able to get in, so we may just have to go in on the full text. But we'll take a look anyway. Okay, where's the abstract? The rate at which aerosols spread from a point source injection, such as from a ship or other stationary pollution source, is critical for accurate representing of subgrid plume spreading in a climate model. Such a climate model results will guide future decisions regarding the feasibility and application of large-scale intentional marine cloud brightening. Prior studies have shown the rate at which ship plume spread may be strongly dependent on meteorological conditions. Let's find our lake. Lake. Where's my lake? Okay, so they did some of this on the Great Lakes. Okay, so they have tried some of these experiments on the Great Lakes. We want to keep them on the Great Lakes, thank you. So we have one. So that would be near where Seth lives. Peering into cloud physics using ultrafine radar and LiDAR. And let's see if we get our lakes anywhere. Okay, we got in and we're going to look for our lakes again. No lake for you. No lake for you. Okay, that's the Sahara. They could be doing it at Lake Chad. We could try that. We'll go hunt for our lakes. Lake Chad. Under a historical scenario, 1975 to 2004, the annual CDD index demonstrated a significantly decreased trend only near Lake Chad in Central Sahara, where the trend was 27 to 53 days a decade. Under RCP45 or G4CDNC scenarios, there was no significant trend over the whole Sahara-Arabian Peninsula. The spatial patterns of the CDD index were quite similar under all scenarios. The eastern part of the Sahara Desert had a brighter CDD index. I don't know what that is. The whole Sahara, it says here the whole, we could actually get back up to where this is and it may tell us. The climatic extreme events predicted to occur more frequently and intensely will significantly be a threat to living residents in arid and semi-arid regions. Therefore, the study aims to assess climatic extremes in response to emerging climate changing mitigation strategy using a marine cloud brightening stream based on the Hadley Center for Global Environmental Model version 2 Earth System Model MCB scheme. This study used 6 climatic extreme indices, i.e. the hottest days, the coolest nights, the warmest spell, and the cold spell, the consecutive dry days, and the wettest consecutive 5 days to analyze the spatiotemporal evolution of climate extreme events in the arid Sahara, Sahel, Arabian Peninsula zone, with and without marine cloud brightening. So again, they never got past the model. Okay. And again, we're doing another, it looks like there's another computer model in here. So, we know that, get my orange pen again, just on computers. So far they're doing it just on computers and observational. They're not doing it in the wild, even at a small scale. So it's not over your house, Seth. It just isn't. Your farm is okay. They could do it on the Great Lakes. It is possible somebody might think of doing it there. You will not see stripes and streaks like a chemtrail. No stripes and streaks. No stripes and streaks. No stripes. So a chemtrail does not look like geoengineering. We also know it's public because we can get to the articles. Now, you have concern about contrails. They are a kind of air pollution. I would be very concerned about the emissions from airplanes. They're gross. Ew, gross. Jet aircraft and pollution might be a search we could do. And I'd be happy to send you the stuff, because they do include air pollution. There's no question contrails include that, but they're not chemtrails, and they're not geoengineering. Geoengineering is a whole different thing. It's either way up above the clouds in the stratosphere. It does not make stripes. Right now, they're working on it just on computer models. Nobody's actively doing it, and you might have it over the Great Lakes, but that's going to be done from ground level, shooting fresh water into clouds. Thank you for watching, and remember, you can catch me live on Twitch.